Welcome back to Explaining Everything, the channel where we dive into the stories and mysteries behind everyday things. Today's question comes from one of our curious viewers, Blender Warlord 84. Thanks for the suggestion, Blender Warlord. You asked, why do certain metals spark when cut or ground? If you've ever watched a grinding wheel hit metal and suddenly it's like a tiny fireworks show, you might have wondered what's actually going on there. Is it just heat? Friction? Some hidden pyrotechnic wizardry? Today, we're diving into the science behind those flying sparks. What causes them? Why only some metals do it? Let's spark some curiosity. Right here on Explaining Everything. Before we get into the why, let's clear up the what. When someone grinds or cuts into metal and sparks fly off, those aren't just pretty lights. What you're seeing are tiny fragments of the metal being torn away, heated to high temperatures by friction and then catching fire, or more accurately, oxidizing as they fly through the air. Each glowing speck is a superheated metal particle, small enough to burn up almost instantly. It's kind of like a sparkler, but instead of a firework stick, it's a cloud of burning microscopic metal bits. They're glowing from both the heat and from the oxidation reaction with oxygen in the air. But here's where it gets interesting. Not every metal does this. Some grind silently with no sparkle at all. So what's the difference? The most common culprit for those bright sparks is iron, or more specifically, iron-based metals like carbon steel, cast iron, or wrought iron. These metals spark because they have just the right balance of properties. They can handle friction, they heat up fast, and when they do, they love to react with oxygen. As the grinding wheel tears bits off the metal, those tiny pieces become red hot from the sheer speed of the process. Once airborne, they react with oxygen and begin to burn. The more reactive the metal and the more heat it builds up, the brighter and more dramatic the sparks. High carbon steels, in particular, are extra spark prone because carbon itself contributes to the show. Burning carbon can create little explosions within those sparks, making them fork or burst mid-air. It's like regular iron sparks, but with a firecracker twist. So, what about metals that don't spark? There are plenty of those too. Metals like aluminum, copper, and titanium usually keep things a lot quieter during grinding. And it's not because they're shy, it's just chemistry and physics. Aluminum, for example, melts before it ever gets hot enough to spark. Its thermal conductivity is so high that heat spreads out too quickly for any one particle to get hot enough to combust. Copper is the same story. Great at conducting heat, but terrible at getting dramatic. Then there's stainless steel. It contains iron, sure, but it also includes chromium, nickel, and other alloying elements that tone down its reactivity. So, it might spark a little, but not nearly as much as regular carbon steel. It's like the chill cousin at a family reunion. Present, but not making a scene. Here's a cool bit of old-school know-how. Blacksmiths and machinists have actually used sparks to identify metals for centuries. It's called the spark test. And yes, it's exactly what it sounds like. Grind a mystery metal and see what kind of sparks it throws. Different metals, and especially different kinds of steel, make different kinds of sparks. Mild steel makes long, bright, consistent sparks. High carbon steel makes wilder, more explosive ones. Cast iron makes shorter, redder sparks that tend to fizzle out fast. Even today, experienced machinists can often tell you what a metal is just by the color, length, and shape of the sparks. It's not super precise, but it's surprisingly effective when you know what to look for. At the heart of all this is a mix of friction, heat, and chemistry. To create a spark, you need three things to line up: a material that can heat up quickly, bits small enough to ignite in air, and enough reactivity with oxygen to keep the particle glowing or burning. Iron checks all those boxes. Its fragments don't just heat up fast, they stay hot, long enough to interact with the oxygen around them. The oxidation reaction releases even more heat, which is why the sparks can appear to flash, burst, or split in midair. So while it might look like random chaos when a cutting disc meets a rusty pipe, it's actually a chain of tiny controlled combustions, which, let's be honest, sounds way cooler. Besides looking awesome in slow-mo videos, sparks tell us a lot about the metal in question. Want to know if something is high-carbon steel? Grind it and watch for branching spark trails. Wondering if a piece is just plain mild steel? Look for steady, unbroken lines of light. Even if you're not a blacksmith or machinist, understanding how and why metals spark can help you appreciate the materials around us. That dramatic light show isn't just friction. It's a tiny chemistry lesson in every flash. And hey, it's a great reminder that the seemingly boring stuff, like grinding a hunk of metal, can turn into something kind of magical when you look close enough. So the next time you see someone sharpening a blade or slicing through steel with a grinder, you'll know that every spark flying off is a tiny science experiment. Friction, heat, and chemistry, all in one flash. If you learned something new about those mesmerizing sparks, don't forget to like, subscribe, and keep your goggles on and your curiosity sharp. Also, if you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for tuning in, and join us next time here in the channel that answers all the why, what, who, where, and how questions you've always wondered about, here on Explaining Everything.